Welcome to Insight Builder channel, large language model automators, artificial intelligence experts, and my dear friends. Demystifying open source model deployment at Hugging Face. Introducing spaces and inference endpoints. In this discussion, we are going to talk about two ways of deploying open source artificial intelligence models inside Hugging Face. One is using spaces and another is using Hugging Face endpoints. If you are new to the artificial intelligence models, Hugging Face Hub, etc., I would suggest that take a look at this particular playlist inside my channel where I discuss about Hugging Face Hub, the various tasks in NLP as well as vision, and also these videos cover the models that are linked with these tasks. And in the same playlist, I also discuss about the process of deploying the models, that is again open source models, in SageMaker, AWS SageMaker also. So let us go back to the presentation for a moment. Apart from Hugging Face, you can deploy these models inside SageMaker, that is AWS, Azure, or you can deploy it in your own endpoints, that is in your own hardware also. Why you might want to do it in your own hardware? Because it will avoid unwanted latency, that is network latency, and it will keep the model and the data secure. So these are the benefits that you get. But these are the options that is available, that is spaces and inference endpoints are the option available inside Hugging Face Hub. And the steps that you are going to take is that you have to decide the task. As I already told you, you need to decide what kind of task you want the artificial intelligence model to do. Once you decide the task, you need to learn about the hardware specs that is available inside Hugging Face Hub. I'll be showing it to you in a couple of minutes. We need to decide the model that you are going to deploy based on the task. And since you have already learned about the hardware, you will know how to choose the hardware now for this particular model. Once you decide what is a model, then you can go ahead with the deployment process and then get the inference or the predictions. So this is the process we are going to take. We will see what are the features of each of these products, that is spaces and inference endpoints. So spaces is deployed inside the Hugging Face Hub. It's basically a web application which is powered through either Streamlit, Gradio, or some of the Docker instances. The spaces has a free tier of 16 GB RAM and 8 CPU core instance. You can have n number of spaces. There is no any restrictions. The spaces are only accessible through Hugging Face Hub website. You cannot access it through any of the external websites. You can embed the spaces, but you cannot access the actual interface from outside the Hugging Face Hub. Also, the inference endpoint, the input for this spaces will be the format that you already provided. So for an example, if you are going to create the space with the file input, then you can only provide file input. If you are going to create it with text input, then only text input you can provide. So such kind of restrictions or limitations are there for spaces. The spaces you need to code. You need to write the particular pipeline code, transformer pipeline code, and initiate the space. You can upgrade these spaces to GPU instance at a cost. So we will be discussing what are the costs in a couple of minutes. This is about spaces. This is a very basic introduction about spaces. Inference endpoints, on the other hand, are like API servers. The inference endpoint can be deployed in AWS or Azure. As I already told, that AWS itself has its own inference endpoint server, that is SageMaker. What I'm talking about here is the endpoint that is created for Hugging Face inside AWS. So this is different. So don't get confused between these two endpoints. I'm just trying to provide a clarity here. In case of inference endpoint, the minimum is 2 GB RAM with 1 vCPU Intel core, and it starts at $0.06 per hour. We'll provide the endpoint, a URL endpoint to which you can send the request. So this is a little bit different from what you saw here. So this is a very bare minimum API endpoint you will have, and you can start working with it and send the request to it, post request to it, and get the predictions from it. It works like the same way how most of the Hugging Face inference endpoints work. it will be accessible outside Hugging Face Hub, as I already told. No code will be written here for deploying the endpoint. So all is taken care by Hugging Face itself. So you need to just follow the user interface that is provided in the Hugging Face Hub, and you can create auto scaling and custom configurations based on your requirement and the model that you're going to deploy. Now comes the interesting part. This is the Open Assistant 6 Llama 30 billion parameter model that was released on 25th of April 2023. This particular model has particular model size is almost 70 GB in size, and in order to make this model to work for you, you need to load all the 70 GB into the RAM or into the GPU RAM or your regular RAM. How are we going to do that? There are a couple of ways to do that. For that, you need to first of all understand the hardware that is available inside Hugging Face Hub. Or if you're going to deploy it inside your own personal hardware, then you need to know what is the size or what is the spec of the hardware that you need to have. Let us start directly with the idea. So idea is that you need to have minimum 80 GB of RAM. Whether it is going to be GPU RAM or regular RAM, you need to have 80 GB of RAM for this model to sit and start working. If it is going to be regular RAM, you can try to work with various endpoints that is already available. You must be knowing you might have even a 96 GB or 128 GB RAM server in your local working environment. So RAM is not a challenge. Getting a RAM where you can load this model is not a challenge. In order to get speed benefits, you need to have GPU. GPU is where the challenge will start. So there are a couple of GPUs in the market. That is, we have NVIDIA T4, NVIDIA A10G, and NVIDIA A100. NVIDIA T4 has a RAM capacity of 16 GB. This is the virtual RAM that I'm talking about, not the system RAM. So this is the visual RAM that is inside the GPU that I'm talking about, which is completely different, has a different kind of a throughput, has a different kind of a processing architecture, etc. T4, we need how many T4s? Think about it. We need at least 6 T4s if we have to load the entire 80 GB of data. If you are going to go for A10G, then we can work with 4 A10Gs. So if you are having 4 A10Gs, then we can go for 96 GB of virtual RAM. If you are going for A100, then we need to have 2. So this is the point that you need to be aware of. And when you are going to work with spaces, again, the same concept comes into picture, and you see the cost per hour. So it will start accumulating based on the time this particular model is up and running inside Hugging Face Hub. So this is something that you need to clearly understand. There are benefits of working with RAM as well as working with GPU. If you are having mission critical products that is going to depend on this particular endpoint, then go for GPU. Now, if you guys are wondering, Kamal, if Open Assistant 30 billion parameter is coming up to 80 GB, then what will be the size of OpenAI's ChatGPT, that is GPT 3.5 or 4. So by just roughly calculating, so for 30 billion parameter we are having 80 GB, then 180, so it is 6 times higher. ChatGPT is 6 times more than this particular 30 billion parameters. So we can say the model size also will be that much bigger. It's not linearly increasing. I am not suggesting that it will linearly increase, but I'm just doing a first principle kind of a calculation. So if it is going to linearly increase, then it should be 6 times into 80. It should be almost 240 GB or almost 250 GB of size. And if it is going to be 250 GB of size, then think about how many GPUs are required, A100 GPUs. So at least 8 A100 GPUs are required. So if you go and take a look at the internet on how many GPUs are required for ChatGPT to work, you will see it's almost 8 GPUs. That's what I remember in the past when I was doing this research. So this is a overall picture that I wanted to give to you guys up on the models, on the hardware, on how to load the model and how to work with these inference endpoints. With that said, now what we are going to do is, as usual, we are going to head for practicing. In this case, we are going to head to Hugging Face for practicing. And I don't have any code to share with you guys because there's no requirement of a code. But yeah, I'll be sharing a couple of space links so you can take a look at those spaces for the code inside that. We'll start with spaces first. So I hope that you guys like this content. Do leave a like, share it with others, and subscribe to my channel for further discussion on similar topics on AI models, large language models, and Python related ecosystem details. So with that said, let us go to the browser. Head to the Hugging Face Hub. Once you go to the Hugging Face Hub, ensure that you have signed up and you have an account there. Head to the spaces, click on spaces. And once you click on spaces, you will be given an opportunity to create a new space. So click on new space. Once you click on new space, this space is basically a GitHub repo inside the Hugging Face Hub server. You need to give the space name, you need to give the license, choose whichever license. At this moment, choose better CC by SA 40. This is the Creative Commons common license that is prevalently used. So use that and choose the SDK that you want to work with. So I am comfortable with Streamlit, so I'll be using Streamlit only. And here is the option, the space option that the hardware that we were discussing. Let us go back to the browser. So this is the hardware option that you'll be getting. This is the hardware option that you'll be getting. I'll be showing that option in a couple of minutes once I deploy the space. Let us go to the browser again. And once you complete all this, then click on public, you will create the space. In my case, I already created it. So I'm not going to create the space again. I'm going to open the space that I already have. So for that, what you need to do is you have to go to your profile. In order to open the space that you are having, you need to go to your profile page, and this is the space you will find it. So GPT-2 experiment. So click on my space. I'll be sharing this link also. This space is shareable. There is no issue. I'll be sharing this link. You can take a look at it. And once you enable a new space, you will not have any files except readme.md. So if you click on readme.md, you will see these are the various data that is inside the readme.md. The SDK that is used, the kind of configurations, the title, etc. will be available, and which is the app file and what is the license, etc. Got it? So this will be only provided to you, and you can clone this repository by using the clone option. So if you click on clone repository, you can clone this entire repo to your local environment. And after you clone it to your local environment, you need to create this requirements.txt and update these two libraries there. So it will get automatically installed when the Streamlit starts. And you need to create this app.py, and you need to write this simple code for getting the GPT-2 model pulled into this environment, that is space, and then you can start making the predictions. Yeah, it is as simple as that. If you thought that, okay, there will be lots of code, actually no. All the code that is required for creating the tokenizer, creating the model, downloading the model, everything is inside this simple single line of code that has been abstracted by pipeline. After you create this, the pipeline will be ready for you to provide the text that you want to predict with, and you will get the prediction output. So let us go to the app. So, okay. What will happen when you are actually deploying it? What will happen is you would have already cloned this particular repository to your local environment. You would open your VS Code or any of your IDEs. You will create the app.py. You will write that code that I showed you right now in files. Then you will git commit it. So you will do the committing to this particular repo, and after that it will start building here. So instead of running, it will say building. And then once the building is complete, you can see the logs here. You see the log, you will see the entire details that is happening, and then you will get this particular user interface, Streamlit user interface. So if I say I am the god Thor, okay, and if I press enter, then what will happen is it will go into the it will start doing the inference. So for this, so here it says, okay, I am God Tongar in your hand. So it totally changed the way I wanted it to create. It did not work out. So you see that how this text generation working inside this space. It's pretty simple. It's you understood how the application app.py is created, how the requirements is Only 4 files are there, and how the app got how it got deployed, the web app got deployed. It's straightforward. Now you know how the spaces work, but let me also add some more information regarding the settings. So this is the settings that I was talking about. This, whenever you're creating the space, ensure that you're using the CPU basic when you're beginning, because you're learning. You need to work with the minimal cost as well as minimal effort. So CPU basic will be sufficient for most of the models, and I already told you how to take a look at the model size. So 16 GB of RAM will be more than sufficient for the GPT-2 model, so you don't have any issue. I think 16 GB of RAM will be sufficient for even I think it will be sufficient for Alpaca LoRa also. You guys can check it out and see how is the output, and based on that decide how to use it. Also, as you go down, you can actually see you can you can delete the space also by using this delete the space option. You can delete the space also. Why I am showing you this is because I always insist on cleaning up. So once your practice is done, ensure that you know how to clean it up, or else there will be unwanted charges that is going to get accrued. Let us go back to the presentation for a moment. So right now you saw how the spaces are getting deployed, how the models in the spaces are getting deployed, and how to provide the necessary input, request to the spaces and get the output. So we saw, and it was pretty straightforward. Right now, next we are going to look at the inference endpoints. You already know the steps. So we know the task. We are going to do text generation. We have seen about the hardware. We have learned about it. And next we also decided the model, that is GPT-2, and we have completed the spaces deployment process inside Hugging Face App. And we also saw the inference process. We have already completed these 3 steps. Now we are going to do this step again for inference endpoint. Right. Let us go to the browser. In the browser, you have to go to this particular, You have to go to the solution and click on inference endpoints. So once you click on inference endpoints, then you will be given this particular page where you can create a new endpoint. So click on create new endpoints. In the model repository, the model repository gets filled by itself. So you see this. So if you click on GPT Dolly V2 12 billion, it will automatically get filled. The endpoint name will get filled. The cloud provider. So currently there is AWS and Azure. So there are 2 cloud providers. Both will get filled. Here I am. Okay. Once you click on this particular drop down, you will see a lot of options here. But in my case of this video, you are not seeing it. So in your interface, in your browser, you can see the various sizes of the instances that I already showed here. I already discussed about that in this particular slide. You can see that also. So don't worry about that you are not able to see it here. Okay. And what I want you guys to understand here is that once you select the model, the instance type gets automatically selected by Hugging Face user interface itself. So for an example, if I try to reduce it, you will immediately see that model may be too large. So the model may be too large for selected instance. So I'm selecting 1x of NVIDIA Tesla T4. But if I select 4x of NVIDIA Tesla T4, then it is sufficient. It is not giving any error. Let me try NVIDIA 810G. So 1x of 810G. Again, it is telling that it may not be sufficient, but I am not very sure of this, because Alpaca Dolly 12 billion will not be more than, I'm not sure, so it might be more than 24 GB. Just give me a moment. So here we are in the Dolly V2 12B model, Databricks model, and we see the PyTorch model is almost 24 GB. Right, and let us go back to the presentation, and we saw that A10G small has 24 GB of virtual RAM. So that means that we cannot actually load it in NVIDIA T4 16 GB. That is not possible. That is ruled out. We have to use at least 2 NVIDIA T4s. Correct. So let us go to the browser again, or we have to use. We cannot use single A10G also, because it is 24 GB, which is very close, correct? So we cannot use that also. So we have to use multiple A10Gs, or we have to use twice the NVIDIA T4 minimum. And A100 will by default work, should not be a problem. So this is how you check the specification and the model. And let us go down here, and if instead of 1x8ng, if I use yeah, there is no 2x8ng, so I have to use 4x NVIDIA Tesla T4 or 1x A100. So you see that these are the options that is available inside Inference Endpoint. This is the first thing that you will decide. And the second thing that you will decide is the advanced configuration. If the inference endpoint is going to be very busy, so if it is going to have a lot of traffic, then better think about providing auto scaling. Also be careful when you're going to provide auto scaling, because if you're going to send a lot of requests, there is going to be a lot of charges involved, and it's not going to be that much high as you give it to OpenAI. But when you're going to work with your local environment, ensure that you properly manage it, because you see, let us not take A100, it's very huge. Let us try, yeah, even this is actually bigger. So let us try NVIDIA T4. So NVIDIA T4 is almost $3,000 per month, and the request that you send the number of requests that you send will actually divide this cost, right? So if you are going to say 300 or 400k request per month, then probably you can break even. So that is something that you guys have to think about when you are doing the costing, and see how it is getting worked, because the model anyway is open source, but the hardware is not. It cannot be open source for that matter, because hardware cannot be free. So it takes power, it takes the material, and it also has depreciation. There are lots of things involved in that. We cannot expect it to be free also, and on top of it there is network bandwidth and availability, service level agreements. I mean, it's a huge thing, and understanding these concepts, these details, actually changes the way you look at the entire ecosystem around the large language models. When we look at the ChatGPT interface, or when we look at the minimalistic looking website, and we see it actually gives you lots of output, we think, okay, the hardware behind this should be very small, but in fact it's not. The ChatGPT, as I was explaining, it takes almost 8 GPUs or 9 GPUs of A100 for giving the inference. I'm not talking about training. I'm just talking about inference from that particular model itself is more than 8 or 9 GPUs. And think about the network bandwidth, think about the redundancies and service level agreements. So it's a huge operation, guys. Okay, let us come back to the discussion here. You can choose the frameworks, you can choose the task that you're going to work with, and ensure that you are going to select public. So after you have done all these things, all you need to do is create the endpoint, and you will be given the endpoint. That is the process that you have to follow for creating the inference endpoints. So it is as simple as that. You don't need to do anything else. Once the endpoint is created, you can actually do the request using curl. So let me show that to you guys in a moment. Just a minute. So this particular create with curl will have all this specification, all this selections in such a way that you can do it programmatically. So you can just copy this, and if you go to your local terminal, you can get the entire. So you can create this instance by using the terminal also. So once the endpoint is up and running, then what will happen is you can use the curl again to start interfacing with the endpoints. So for an example, I will get the endpoint like this. I will have the endpoint with a name like this, which will have the AWS endpoint huggingface.cloud, and you can give the input. Let me click here, just a minute. Yeah, you can give the input as a post request here, and you can give the bearer token with HF token here. That is read token. This should be your HF read token. If you are not aware of how to create it, just do a document search inside Hugging Face Hub. It's pretty straightforward. And then you can use the content type as application and JSON, and you can get the request. This is an example request that I'm showing it to you guys. And also, let us go back to the browser. Let me take to the model space, so that I want to show you something. The way the inference endpoint gets created, right? So if you go to any of the model that is already available, you will see, okay, in this case there is no inference endpoint, so it has been turned off here. So we can actually turn off the inference endpoint like this also. So let us go to the GPT-2 model, so that you can see what I'm telling about. So GPT-2, and when we do GPT-2, we see that we have this kind of a inference endpoint, right? The same way you will get in your in this area also. So once you complete it, you will get that inference endpoint. As I was telling, be careful about the charges involved, and also be careful about the type of instance that you are creating and the cost involved for that creation. And here is the contact us link that I was talking about. If you want bigger instances, or if you want a different kind of instance, or if you want to discuss with them about the quota, with Hugging Face about the quota. So this is something that you guys have to be knowledgeable about. And I hope that with this particular discussion, you have got an overview of how to work with both inference endpoint as well as spaces, and how to get the outputs. You can deploy any kind of model, as I was talking about, for any kind of task. So there are lots of models and lots of tasks there. You need to also do some research, and as I was telling in my playlist, I have been doing that specific task only, that is researching about various models and various benefits of each of these models. And with that said, I would like to come to a close of this particular discussion. I hope that you like this content. Do leave a like and share it with others, because this is a new technology. People have lots of doubts on how to make the deployment happen, what will happen when they are deploying, what will be the challenges that they will face. Also, one more important point I forgot to add. Let me go back to the browser. When you are working with the spaces, right? As I was telling, when you're working with the spaces, this spaces will create a GitHub repo. And when you want to work with the GitHub repo, you will have to make a git pull or git push. You want to git commit, correct? What will be the password that you're going to use, or what will be the username? The username will be the profile username that you have. Like in my case, it's Kamal JP, and the password will be the HF write. So there will be a token called as HF write. If you go to your profile, if you go to settings, go into settings, and inside the settings you will actually get the access tokens. So click on access tokens, and inside the access tokens you can get the tokens and you can use the tokens, right? So this is what I was talking about. So this tokens inside when you click new token, you can make a write token, and that write token is what you have to use it as a password. This is something that I forgot to add it in the beginning. So I hope that now you are clear. So I'm talking about this particular spaces step. So in the spaces, when you are going to work with GitHub repo, then yeah, all these steps you need to follow, and you have to use the HF write token for writing to the GitHub repo, writing to the Hugging Face GitHub repo, not the GitHub, the github.com GitHub repo. So I hope that you have an overall picture of what I have been discussing about. You can see how the model can be deployed to the Hugging Face Hub, as well as I also discussed about how you can use spaces and inference endpoints inside Hugging Face Hub. And as an option, we can think about deploying it in AWS SageMaker too. And then we discussed about the model size. We discussed about the various specifications of the instances that is available. And finally, we did some practicing. With that, I would like to close this video. Also, do subscribe to my channel for further updates on similar content, so that also once you subscribe, any of the videos that I upload will directly hit your YouTube dashboard, and you will be up to date on topics that is related to artificial intelligence, automation. And I have also started a different series on automate with AI. So all those videos also will start hitting your YouTube dashboard directly. So do subscribe. And with that said, I would like to leave with 4 words, that is practice, 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 practice. See you guys. Have a great time.